Let's talk about how we solve or find solution sets to what are called compound inequalities. Now, compound inequalities often present as either two separate problems and we have to satisfy one or both of them at the same time, or they can be presented as almost like a bounded inequality. And I'm going to go through all of those types in this video. So let's start with this. So you can see here I've said that x minus 4 has to be greater than 2, or negative 2 times x has to be greater than or equal to 4. Now, this word or, this means we have to find an x that satisfies one or the other. So let's solve both of these. Let me add 4 to both sides for this. So I have x is greater than 6. So if we were to graph that, of course, greater than means we are going to put an open circle at 6. And greater than means it's going to be all of this up here. The next one, to solve that, we divide both sides by negative 2. And just remember, when you divide by a negative, so we should right away just change this as soon as we're dividing by our negative to face this way. You reverse the inequality the way it faces. And the reason we do that is we're flipping our sign, so we flip our solution set. So in this case, x is less than or equal to negative 2. So that means we're going to put a closed circle on negative 2 and shade everything that is less than that. Okay. Now, because of this word or, we're just saying we need one of these two things to be satisfied. So any values down here would satisfy the first equation, and any values up here would satisfy the second. So all I need to do is be in one of those spots. Now I'm just going to kind of darken this up. This is my solution, is that stuff on the number line. So really only that stuff in the middle doesn't work. Let's do another. 3 times x plus 1 is greater than or equal to 7, and x minus 9 is less than negative 2. So now the word and changes this a little bit, because now we're talking about an x that satisfies both. So it's not enough to do one or the other. It actually has to be the solutions that will work for both. But again, the algebra is not going to change. We're going to start by subtracting 1. So we have 3x is greater than or equal to 6. We're going to divide both sides by 3. And we get that x is greater than or equal to 2. So greater than or equal to, we're going to put a closed circle on 2. And we're going to say, well, everything bigger than that. Okay. Next up, we have x minus 9 is less than negative 2. Well, of course, I'm just going to add 9 to both sides. X is less than 7. So now, less than, I'm going to put an open circle on 7, and I'm going to draw all the stuff that's less than. But remember, this word and means it has to be the stuff that works for both. Well, right in here, in between the two kind of ends that we drew, these numbers that are double shaded, this is the spot that will work for both. So what we have to do is, and I'm going to darken this again, I'm going to say we have this closed circle at 2, we have this open circle at 7, and it's all of the stuff that is in between. And all of the other stuff can just get erased because that is not part of the solution set that will work for both. So again, be very careful. The word or means it just has to satisfy one of the inequalities to work, and means it needs to be the solution set that works for both. And you could plug in a number if you wanted. You could say, well, what if I tried 4? 3 times 4 plus 1 is 13. That's bigger than 7. And 4 minus 9 is -5. That's less than -2. So you can see this is the set of numbers that will work for both. So just read carefully. It doesn't change the algebra, but it lets you know, am I worried about kind of finding that overlap, that double shaded part, or is it enough to just plot them separately and be done? Let's do one more type of compound inequality. Now in this case, you can see I've bounded an equation. I've said that 2 times x plus 5 has to be greater than or equal to 1. So the x's that when I plug in come out bigger than 1, but it also has to be less than 17. Now, solving this is just a little bit different, or looks a little bit different, because you certainly could like write this down twice. We could write, 2x plus 5 is bigger than 1, 2x plus 5. But I would urge you to just solve all of this at once. So think to yourself, the first thing I'd like to do is subtract 5. And if I'm really solving two algebra problems at once, which means I'm going to subtract 5 from both sides. So I've got -4 is less than or equal to 2x, which is less than 12, like that. And then, again, I'll divide by 2, and I'll do that to everything. So I've got -2 is less than or equal to x, which is less than 6. And this actually very nicely bounded. We have this, greater than or equal to -2. So I'm going to put this. I've got a less than 6, like this. And it's simply the values that are in between. These are the values that work. And again, you might want to just, check. It's never a bad idea when you're shading to pick a number. And I think 0 would be real easy to pick because that's inside this solution set. 2 times 0 plus 5 is 5. That's greater than or equal to 1. And it's less than 17. So I have shaded correctly. So these are the different types of compound inequalities. You can have two statements joined by an or, where you just have to figure out, solve them each separately and figure out the solutions on the number set that will work for one of the two. Then you have to solve the two equations and figure out what will work for both of them. Or one like this, where you have the equation and it's simply bounded by like an upper and lower number. If this video helped you, please like and subscribe for more math help.